Let us look at control flow. We have conditionals in Python. You can test, for instance, whether 3 is smaller than 4. The answer will be true. There are other operators. One is in. Okay, you can test whether an element belongs to a list or to a dictionary key. You can also have is and is not, which is especially useful to test whether something is none or not. For example, I can say via list comprehension, give me A for A in this list if A is not none. So here is a list that contains one none element, but because I want the A's for A in the list that are not none, I will get the list except for the none element. Okay, for the if statement, we have the if, elif, and else. Elif means else if. So for instance, I can test if x modulo 2 is 0, so it's if x is even, I print that is even, and otherwise I print is odd. This is an example of an if-else. Notice that there is no end if. The indentation tells you when the statement is over. Then I can start another if statement and say if x modulo 3 is 0, I print your multiple of 3. Otherwise, if the remainder is 1, I print something, and in the last case, I print something else still, right? So I can run these. This is put into a loop for x that is in range 10. So this will produce essentially 0, 1, 2, etc. up to 9. Range is a quick way to build these number ranges. And if we do these, we get the following. Okay, so we get all this information about whether numbers are even or odd, or what's their modulus dividing them by 3. One useful thing is that if then else can also work as an expression. For example, I can say x is equal to 3, and I can say y is equal to x plus 1 if x is greater than 0, else minus x plus 1. Okay, so the thing is that you first put the expression in case the conditional is true, and after the else, instead you put the expression you're going to use if the condition is false. So if you run these, you get 4, and if you converted this to a minus 3, you would also get 4. Okay, so this is quite handy to be able to do this if then else in line to return as part of an expression. This is an example in a list comprehension. I can say give me x if the remainder of division by 2 is 0, so if x is even, else give me minus x if x is odd, for x in range 10 again, and you can see that this gives us the number itself if the number is even, and minus the number if it's odd. So we can write in a single blow these kind of expressions. Iteration. The simplest iterator is for, and the typical way you use it in Python is that you say for element in something that can be iterated upon, which normally is a list of something that is list-like. For example, I can build a list of words. Here I write a sentence and a long string, and then I say dot split, which splits it according to white space. And then I say for w in my words, print my word is and the word, right? So this is a typical way in which you iterate in Python. You do not really keep an iteration index. You simply have a list of stuff, or maybe an iterator of stuff, like when we had the dictionaries before and we wanted to iterate on the keys of a dictionaries. And we say for element in list of stuff. Okay? Now, sometimes you do need also to have the index of the iteration. And so you have this enumerate helper. If you have a list, you can enumerate it and you obtain a list of pairs that is index and element. So if you say for I, w in enumerate of my words, you will iterate in such a way that I will be the index of the word and W will be the word itself. Okay, I think it's almost easier to see it than talking about it. You see, I gets values 0, 1, 2, 3 up to 9, and W gets the words. I like to eat pizza, yada yada. Okay? So this is very useful, to iterate having both the index of the element and the element itself. So if you iterate and you realize you can stop iterating, you can break out of the iteration. Okay, for example, here you are looking at all the words. You print the word, and if the word starts with anchovies, you break out of the loop. Okay, so I like to eat pizza with anchovies, and this would continue, but because this word anchovies comma starts with anchovies, you break out of the loop and say, indeed, they're delicious, no need to say more, and so you break out of the loop. Okay. I already mentioned the range is a way to create integer ranges on which you can iterate. Okay. You can print this incredibly large range, and your computer will not actually blow up, because a range is not really a list. It's simply an indication of the extent of numbers over which you want to iterate. So a range is represented implicitly inside the execution system of Python. It's not represented by creating a list of so many elements and then enabling you to iterate on it. Okay? You can iterate over list slices. So if I want to iterate over the first 5 words, I can use the slicing notation we saw for lists. This will get elements up to the 5th, with the 5th excluded. So elements 0, 1, 2, 3, 4, which are 5 elements. Okay, I like to eat pizza. You see 1, 2, 3, 4, 5 elements in total. And you can iterate, as we saw, over the keys or key value pairs of a dictionary. This we saw it already when we were talking about dictionaries. Okay? So this all works. There is also a while statement, which works as usual. It has a condition, and as long as the condition is true, you loop around, so you continue executing the iteration. And of course, you can also break, just as you can break out of a for loop, you can also break out of a while loop. There is another statement that I do not have an example here for, that is called continue, which means, hey, finish this iteration, don't finish this iteration, skip to the next one, please. I use it less frequently, and so I skipped in this tutorial, but you can look it up. So, exceptions. In Python, when you have an error, an exception is raised. We saw already the key exception when we try to look up something in a dictionary that doesn't quite exist. Okay? Now you can also catch exceptions to prescribe yourself other behaviors in case errors arise. For example, I can do here try x is equal to 34 divided by a except x is equal to none. So if there is an exception raised here, I say that x is equal to none. And if I run this code, because this divided by a string, this division by a string doesn't make sense and generates an error, the result will be none. The module traceback enables you to print these exceptions and to format them as strings. So you can look at the documentation of it, but what you can do is then print intelligible error messages. Unsupported operand types for divide, integer, and a string. You cannot divide an integer by a string. You can also, and this is very useful and will be useful to us, you can define and raise your own exceptions. So you can define your own special cases of errors. For example, here I define an error that is called indigestion. For something to be an exception, it has to subclass the exception class. So it's a class indigestion that is a subclass of exception. And so it inherits the ability to be raised. So I define this indigestion exception, and then I define it of this M and L, and if my list L is bigger than 2, I raise indigestion, okay? I just define this a bit for the fun of it. And so if I try to eat bananas on this list L that contains 3 elements, this will raise an indigestion, and this indigestion exception, I can catch it, and I can say, hey, that's too much, instead of blowing up, right? So if I simply say, let me show you this. If I simply say this without the try, let me put it above. If I simply say this will give me an indigestion error, okay? Indigestion. I could have given here a message like ouch, okay? And this would, indigestion ouch, would be the error, okay? And if I catch it via the try except construct, I can try this eat invocation that erases the exception, except that if I have an indigestion, I can print, hey, that's too much. In which case I catch the exception, you see there is no resulting error, and the except clause is executed.